Hello everybody. Today I'm gonna show you a nice and easy way that you can use Microsoft Excel to do the McCabe Thiele diagram instead of doing the drawing manually and get a more accurate diagram. So before I start with Excel, I would just revise quickly the McCabe Thiele diagram. So the steps are as follow. We first draw the diagram, the XY diagram. You draw the 45 degrees line, then you draw the equilibrium curve, and then put the concentrations or the compositions of the feed, the top section and the bottom, or the top product and bottom product, the XD, XF and XW. And then you know that the top section is the intersection, or it's the line that starts with XD and XD and ends with XD over R plus 1 at X equals 0, and this is the top section. And then you should know that there is a Q line which starts with the feed, and then it depends on the phase, which phase the feed is in, and then you draw the line using the slope, and I'll go to this in like few slides. And then you get the intersection of the top and bottom sections from that point that we have here, and then you use it to draw the bottom line or bottom section line by connecting this point to the XW and XW point. So then you can draw the stages as we saw last time. So this is briefly what we said in the previous two videos. And then we said that you need to know the reflux ratio, which is the R, and in order to get it you need to calculate the minimum reflux ratio, which is the intersection of the you get the pinch point, which is the intersection of the Q line and the equilibrium curve, and then you connect this point, the pinch point, with the top section line point, which is XD and XD, and then the that point is XD over 1 over XD over 1 plus R minimum. And then this R minimum is not the one that you're gonna use in your system. You'll multiply it by 20% or whatever, and then this is the value of the R actual that you're gonna use. So yeah, it depends, maybe 20 or 30%. So there are two things I just need to say before I go to Excel. So they're kind of mathematical stuff, but it's important in doing this in Excel. So one thing we will do is to draw the Q line, and we know the Q line starts with X feed and X feed on the 45 degrees line, and then it somehow is connected with another point, and then you can draw the Q line. So actually what we know is that this is the equation, and we know only the point which is X feed and X feed, but you don't know the other point, you just know the slope. So how you can use the slope? So it's pretty simple. Actually you can use the slope and one point to get the other point, and this is simple. You know that the slope is delta y over delta x. You know one x and one y, then you assume another x, and you calculate the other y. So you now can get the y2 from any assumed value of x2, and since it's a straight line, then so any point would work. You don't need to worry about this. And now you have another point, and then you can draw it very simply. The other thing is how to get the intersection of the top section line and the Q line. Actually it's something that's very famous in mathematics, is how to get the intersection of two lines by equating them together, like put the first and second equal to each other, or calculate, or I mean solving them together. And this is the point that we are trying to get, and these are the two equations that we have, and for the sake of simplicity I'll make them in that form, a1x plus b1 and a2x plus b2. So I know that a1 is r over r plus 1 and b1 is xd over 1 plus r, and the same here. So to solve them together you will get that form of the equation, which will end up with that shape. So you can simply calculate all these constants, because you know all these values from the from your problem that you have, and then you can substitute with this x in any one of these two equations to get the y, and then you have another point. You can connect these two. I mean you now know the point, the x2 and y2, and then you can connect this with the bottom section other point. So that's all, and then let's go to Excel. So before I start with Excel, I just wanna point out something that's really important. This is a program that you're gonna make by yourself for your problem. So Excel doesn't understand that this is distillation, doesn't understand that this is any concentrations or compositions or stages or equilibrium, or it doesn't understand anything. So it's not like any simulation software. It will like give you an error message or pop up any problem that happens with your calculations of the input. It will just put or show you whatever you put, either it's right or wrong. So you need to be cautious because there might be something wrong and you wouldn't notice this. So the way we're gonna go with this is by putting just lines on a plot, and there will be like a lot of lines, one for the equilibrium, one for the 45, and one for top section, one for bottom section. So to be like group of lines, and this is not a big deal. Excel will just do everything, but you need to make sure that you give the inputs right, so it plots it right. So for our case, what we have here, we have the three compositions or concentrations of the feed, top section and bottom section. You have a feed of 55% of A and B. I don't care what is A and B, just an example of A and B. And of course, these compositions are of the more volatile component. So the XD is 95% and XW is 5%. And you know that the value of Q is 0.75. So the feed is like in the wet region, it's half vaporized, or 75% of this is vaporized. And I calculated the slope of the Q line. It's Q over Q minus 1. So I have it already. And I know these are the top section would be from 0 to 1, 0, 0 to 1, 1. So let's start with the the 45 degrees because it is simple. So what I'm gonna do is go to insert and then scatter, and here you go. So now this is the first thing. I'll just do some edits to the figure so it looks more like the McCabe Thiele diagram that we all know. So what I'm gonna do now is um, so the plot has to start with 0 and end with 1. It cannot exceed that. And the same for the other guy, start with 0 and end with 1. So now you have the two axes like this. I just need to make it every 0.1. I prefer to have a border. There are like a bunch of things you can do, like you can make the border style with like thicker, whatever. Oh, I'm sorry, I did something. Yeah, it's here. So you can make no tick marks here, no tick marks here, just so it's not gonna make any difference, just to make it look more familiar. And then I prefer to have like a border here, just to have everything like what we are used for. I'm sorry, I like to make it look nice, so it wouldn't take much time. So here we're almost done. So I have here one thing here, which is the so it's not actually done. So sometimes this happens. It flips the um, oops, sorry. It flips the axes or the x and y. So if you have any problem, you can go to select data. I prefer to rename every one. So I'll say this is the 45 degrees line. So I know that this is the 45 degrees line. And here you have the 2 points. I don't want points, I want it to be lines, so I need no markers. I need line style to be thin, so they don't make trouble. So now you have something which is more familiar than it was before. Now we need to put the points that we have. So I know that the top section starts with XD and XD, so I'll link everything to the initial values that I have here, and I'll tell you at the end why I'm doing this. So I have the Q line starts with X feed and X feed, so I didn't do any calculations yet. I'm just putting the inputs that I have, and the bottom section is 1 point is X W and XW. So let's see what we have now. We need to plot the equilibrium curve. So one form of the equilibrium relation is this. It's alpha x over 1 minus 1 minus alpha x, which is one sort of equation that's kind of famous. And the alpha is the relative volatility, and actually we have it here as 3. And this is the vapor pressure of the more volatile over the vapor pressure of the less volatile. So it tells you how easy or difficult the separation was. So what I'm gonna do is to put values starting from 0 to 1 with 0.1 increment, and calculate the y for each of one of them. So it will be alpha, and then I'll do f4 multiplied by x divided by 1 minus 1, or oops, minus alpha and 1 f4 multiplied by x, and here we go. So I'll get all these points, and then select data, and I'll add another line to the plot, and it's called equilibrium. So as you see, you just need to um, get the points and to just put them in the plot. So here it goes. Uh, it is kind of thick. I prefer to make it thin actually, and you'll see at the end, if you have close points, it will be easier for you to make them very thin lines, so you know which is which. One nice thing here is you can make it this a smooth line, so it's not a broken line, so it is easier or better to see. uh, I prefer to make this very thin, and to make it like dotted so it doesn't disturb. Okay, so here you have the equilibrium and 45 degrees line. You need to go for the top section, bottom section. So you start with top section, Q line, and then bottom section. So the top section, as we know, you need to know the R minimum, and R minimum depends on the Q line. So Q line would be the first thing to try. So we know, as we said, the Q line, you have a slope and you have the one point, and then to get the other point you need to assume a value of x. So I know the Q line would go something like this, so the x would be smaller, so I'll assume a value of x of 0.2, and then I'll get the y of this corresponding to this from the slope. So as we said, it will be x2 minus x feed multiplied by the slope, and this is plus x feed. So you have here these 2 points. It's 1.6, which is too much, so make it 0.3 or zero point 0.4. Yeah, okay, so I can plot this. This is not very accurate. It is x2 minus xf multiplied by the slope plus x feed. Okay, yeah, let's so it looks right. So I'll select data and then add, and then I'll say Q line, and the x would be this and y would be this. Okay, so yeah, here it comes, and I'll make this line thinner. So now we have the Q line, and we can see what is the R minimum. So let's draw the top section. But the top section, actually, to get it, you have to assume a value of R. We know that the other point is 0 and the y is xd over 1 plus r, but actually you don't know what is the value of r. You need to get the r minimum. I'll get this here, try to make it bigger so you can see it easily, because it's kind of not very easy to see. I'll just put it here. You don't need to see this anymore. So I'll assume a value of R minimum, let's say 1, and then use it to calculate or plot the top section line. So it will be xd over 1 plus R minimum. So now we need to get just the pinch point and to use it to get the R minimum. So we'll get a select data and add the top section, and the x values will be this and y values will be this, and you press okay. So it's not actually very accurate. You still have some distance here, so you need to decrease it a little bit. So I'll try 0.9. It looks almost there, but it's not very good, so I'll try 0.88, 0.85. Okay, 0.85 looks good. So let's assume 0.85 is the right answer. Let's make it thin. Okay, so now we know that the R minimum is 0.85. So to get the right R, you multiply it by, we said, by 1.25 for instance, and then you have okay, you have the value. This is the actual value of the reflux ratio. So to plot the right um, uh, top section, you just need to get this to be calculated from the actual R. So now you know that this is the top section, starts here and ends here. Pretty simple, nothing no problems. And now to go to the bottom section, you need to get this intersection. I know this point, which is 0.05, but I don't know that point. So to get this point, we said you need to calculate A1, A2, A3, and B1, B2, and from these to get the point of intersection. So A1 would be R over 1 plus R, and A2 equals xd over 1 plus R, which is this, and B1 would be the slope, which is minus 3. Oops. So I already calculated them before, so I don't need to do the calculations anymore. So I'm sorry, I did something wrong. Um, this is B1. I'm sorry. This is B1, which is xd over 1 plus R, but A2 would be the slope. Yeah, I got confused. So just this here and this here. And for the B2 would be negative x feed, which is this, multiplied by or divided by Q minus 1. So here I have all the points, and to get x, you just calculate it from B2 minus B1 divided by A1 minus A2, and then y would be calculated from any one of the two equations, which is A1 multiplied by x plus B1. So now you have A1 multiplied by plus b1, this value. So now you have the 2 points. In order to check that, looks like right, it's around 0.5 and 0.7 something, which is right. To make sure that you're right, you need to plot the bottom section, and if it starts at the same point, then you're right. So this is the last step here. You'll add the bottom section, and the x would be these points and y would be these points, and voila, yeah, here it goes. It looks perfect. So the line style, I'll make it thinner, and now your plot is ready. You have the Q line, top section and bottom section. Now you know that this is the top part of the plot, the bottom part of the plot. The nice thing about it is that when you go ahead and do any other change in the unit system, let's say you make it at 0.9, it will automatically change everything. If you change the Q from 0.75 to 0.5, for instance, then your plot will automatically change everything. And let's say you'll make it this 0.2, it will do every change without any problem. You can make it 0.1, you'll make it and it will be pretty nice if you have high concentration of the top section and very low concentration of bottom section. It will be like the actual case. But the only problem here is that you need to make sure if you change anything in the system that the R minimum would be recalculated. Other than this, you're gonna be good to go. And this depends on the Q. So our Q was 0.75, so you need to stick to it and then do other calculations in case you need to change anything. So this is almost everything for today. So now you can draw your plot, and you can print it and then draw the stages by yourself, or wait for the next video where I'm gonna show you how to draw the stages like the same thing we did today. So I'll see you next time, inshallah. Bye bye.